We will now discuss the solution of a problem from the section Vector Algebra. This question has appeared in the Joint Entrance Examination Main held on 24th June 2022 in the second shift. The problem is, let A cap and B cap be two unit vectors such that modulus of A cap plus B cap plus 2 times A cap cross B cap is equal to 2. If theta belongs to the open interval 0, pi is the angle between A cap and B cap, then among the statements S1, first statement is 2 into modulus of A cap cross B cap is equal to modulus of A cap minus B cap. S2, statement 2. The projection of A cap and A cap plus B cap is 1 by 2. We are given 4 options. Option A, only S1 is true. Option B, only S2 is true. Option C, both S1 and S2 are true. Option D, both S1 and S2 are false. We are given two vectors, two unit vectors, A cap and B cap, and they satisfy this equation. And if theta is given to be coming from an open interval 0, pi, and it is the angle between A cap and B cap, then among these two statements S1 and S2, which of the following options is true? That is the question. So this is the given question. We will now discuss the solution of the problem in detail. We are given three conditions. The first one is A and B. Now this cap, calling cap A cap, B cap will drop, and we will say A and B are two unit vectors. The meaning of that is the modulus of A and the modulus of B is 1. Option 2, modulus of A plus B plus 2 into A into B, A cross B, 2 into A cross B is equal to 2, and theta comes from the open interval 0, pi, and it is given to be the angle between A and B. So this is about the modulus of the vectors, and this is the theta coming from this. Now what exactly theta is, that is the question. So therefore we have to take this second condition and see what will be the value of theta for which this is true. So let's look into it in the next slide. We take the condition 2, modulus of A plus B plus 2 into A cross B is equal to 2. And squaring on both sides, we get A plus B, modulus of A plus B plus 2 into A cross B square is equal to 2 square. And you know, if a vector x is there, and modulus of that vector x will be x dot x. So you take this vector, make a dot product with itself, that will give you the modulus square. So that's the vector here. Dot the same vector is equal to 4. Now take the dot product. If you take the dot product, you will get a plus b mod square, a plus b dot a plus b, that is a plus b mod square, and 2 into a cross b multiplied by a plus b, and from here a plus b multiplied by 2 into a cross b, so they are to be added, and the dot product is commutative. Therefore 4 into a plus b dot a cross b plus 4 modulus of a cross b square is equal to 4. So now in this, what is this value? What is this value? So here we see in the snippet a bar plus b bar dot a cross b, use the distributive law, will get a dot a cross b plus b dot a cross b. Now this is the scalar triple product of three vectors, and it is written as in brackets, that is the scalar triple product, box product. So that is a b, and if you see, that means the box product of a, the vector a with itself, and b, and if you take its box product, the answer will you will get in the determinants, and in the determinant a, the components of a will be first row, in the second row the components of a, and in the third row the components of b will be there. So what you see is two rows are identical, therefore this box product, the scalar triple product, is 0. And so also here, so also in the second case. So that is b and b is repeated, therefore two rows are equal in the determinant, therefore it is 0 plus 0 is 0. So this middle term here, this will be 0. So that will imply a plus b mod square plus 4 into a cross b mod square is equal to 4. Now we see what is a plus b square. So we have a plus modulus a plus b square is the vector dot with itself. Take the dot product, you will get a dot with a is a mod of a square plus a dot b plus b dot a, but the dot product is commutative, that will be 2 into a dot b plus mod b square. These are unit vectors. Therefore, modulus of a is 1, modulus of b is 1. That will be equal to 1 plus 2 into the dot product of a with b is modulus of a into modulus of b, cos of the angle between them, that is cos theta. So this will be equal to 2 plus 2 cos theta, because modulus of a is equal to modulus of b is equal to 1, and it is 2 plus 2 cos theta. So for this you can write 2 plus 2 cos theta. We see what is a cross b modulus. The modulus of a cross b, the modulus of a into modulus of b into sine of the angle between them, and multiplied by the unit vector perpendicular normal to the plane containing both a and b. And the modulus of a is 1, this is 1, and it will be modulus of sine theta into n hat, that is n cap, and n cap is a unit vector. When you take the modulus, that will become 1, and this is equal to mod of sine theta, and when you square it, it is sine square theta. It is sine square theta. Substitute here, come back. So for this, 2 plus 2 cos theta plus 4 sine square theta is equal to 4. Now send this 4 sine square theta onto the right hand side, and you will get 2 plus 2 cos theta is equal to 4 into 1 minus sin square theta, that is 4 cos square theta. Now everything is turned up in cos, so write it. Now 2 is common throughout, so cancel that and rearrange the terms. Then after simplification you'll get 2 cos square theta minus cos theta minus 1 is equal to 0. Now it is a quadratic in cos theta, so we can write uh, the factorizations. So the factorization is very easy. Here first factor is 2 cos theta plus 1 multiplied by the second factor is cos theta minus 1 is equal to 0. This will imply cos theta will be equal to minus 1 by 2 or cos theta is equal to 1. Now cos theta is equal to minus 1 by 2 when theta belongs to 0 to pi, then it is theta is 2 pi by 3, then it will be minus 1 by 2. So theta is 2 pi by 3, and we reject cos theta is equal to 1 because theta belongs to the open interval 0 to pi. So cos theta is 1 when theta is equal to 0, but that is not there in the open interval. Therefore, it has a for no theta in this one, cos theta is equal to 1. Therefore, we reject. So theta is equal to 2 pi by 3. So that's what we wanted. Now we are ready to go into the statement 1 and statement 2 in the next slide. So we have theta is equal to 2 pi by 3, and modulus of a cross b is modulus of sine theta. This I have already derived and it was there in the last slide. And modulus of a plus b is equal to, for the square, the answer was 2 plus 2 cos theta. Without the square, it is under the square root of 2 plus 2 cos theta. Let's get into the statement 1. S1, this is given to be equal to 2 into mod of a cross b is equal to mod of a minus b. So let's take the left hand side, that is 2 into mod of a cross b. So mod of a cross b is mod of sine theta. So it is 2 times sine theta, and that is 2 times modulus of sine of theta is 2 pi by 3, and this is 2 pi by 3 means sine 120 degrees, and that is equal to root 3 by 2 the answer. So 2 into root 3 by 2, 2 cancels, we get the root 3. That is left hand side is root 3. Let's take the right hand side, and modulus of a vector a minus b is equal to, you will get the answer is, it is per plus, this is the thing, and for modulus of a minus b, it must be under the square root of 2 minus 2 cos theta. But anyway, here I have multiplied, they taken the dot product with itself, and we have used modulus of a into modulus of b is 1, and a dot b is equal to modulus of a into modulus of b into cos theta, and all that we have made and simplified. You get under the square root of 2 minus 2 cos theta. For theta is 2 pi by 3, under the square root of 2 minus 2 cos 2 pi by 3, and cos 2 pi by 3 value is a negative, that is 1 by 2, 1 by 2, and this is a 2 plus 2 into 1 by 2 under the square root, and this is 2 plus 1, that is under the square root is root 3. So the left hand side is root 3, right hand side is root 3. Therefore, our statement S1 is true. Agreed. Now let's get into the statement S2. The projection of A, the vector A, on vector A plus vector B is 1 by 2. Is it true? That's the question. And we recall the formula for the projection of A on A plus B is, it is a quotient where the numerator is A dot A plus B by the modulus of A plus B. So A dot A is mod square, mod of A square, that is 1. A dot B is mod A into mod B into cos theta, that is just cos theta, and that is equal to 1 plus cos theta by modulus of A plus B is under the square root of 2 plus 2 cos theta. Now substitute for theta 2 pi by 3 and use this value cos 2 pi by 3 is minus 1 by 2. Minus 1 by 2. So it will be 1 minus 1 by 2 by the denominator under the square root of 2 plus 2 into minus 1 by 2. So when you simplify, the denominator is 1 and the numerator is 1 by 2. So the answer is 1 by 2. So thus the projection of A on A plus B is 1 by 2. So that means the statement given S2 is also true. Thus, both the statements S1 and S2 are true. Let's look at our options. And our answer, both S1 and S2 are true, appears against option C. Therefore, the answer for this question is option C. And it is definitely a good problem. And I am sure that you have understood the solution of this problem. And I wish you all the best. Thank you.